All right, it's Thursday, day 4 for programming. Okay, we talked about make sure you log out, turn the monitors off. Then I talked about focus in terms of staying, focused to the task at hand in class or anywhere when they're trying to solve a problem or work on something. You can't be multitasking. You can't be doing lots of things. So we talked about phone usage in class unless you absolutely have to check something, and don't pack up before we're done, and so forth. Being able to stay focused on the problems that we're working on in class. Structures, sequence. You go straight down, one process after another. Couple teaching points, the arrows straight down, a process box, one in, one out. We'll mention those. And the arrows just touch, they just touch, okay? And we always work in this kind of pattern. We always work in a down and to the right, as best we can. And we're going to talk about things that come up later on. In sequence, you have an action word and some command in order for the pseudocode. Okay? Action word, do some, action word, do some. And it'd be a nice straight line here on the edge. Now, if we take a look here at a conditional, a conditional is, alright, so if we take a look here at a conditional, we make a decision. I'll use a different color here. Make a decision. The arrow comes in, just touches. If the decision's true, we do one thing. If the decision's false, we do the other. Okay. Now there can be lots of things done in between here. It could be 5 lines, could be 1,000, could be more conditions, more sequence, whatever. But for this if-then, it always has to come back together. Okay? So if we were to look at some information dealing with that, let's say we have an if-then, okay, and we'll see the word else and if, okay. This is like the end if right here. And let's look at that. Let's look at that in pseudocode. So we have if, and we have some conditional. That's going to turn out to be true or false. If, then, the true part's here. In this case right there. Else, the false part's here. In this case, this part right here. And then we have an end if. That's like the circle up above, where everything comes together, and then we continue on in the program. You notice lines just touching, straight, working down, then eventually if we had to, we'd work to the right. Okay, so we have a condition. Next one, we have iteration. 2 different ones. We have a leading decision, the decision's here at the beginning, and we have a trailing decision, the decision's at the end. Again, we don't know how much work's going to be done in here. It could be thousands of lines, could be 5 lines, whatever. Same thing here. You see the big difference, though, if we were to look at this more closely. Here, we use a do while, and if it's true, we're going to do the work. Here, we're going to do the work once for sure, and then we're going to say, are we done? If it's true, then we go on with the program. If it's not true, we're going to do the work again. Come back here, come in, do the work again. See the difference? No processing there between the connector in here, and no processing here between here and the connector. All the processing has to be either in here or in here. So let's take a look then at the pseudocode. Do while, here's the condition, we indent, this is the true part, and do. So as long as that's true, this keeps coming back up. As soon as it's false, we go this way. So a do until, even though we write it up here, we come in here and we check the end do. The end do keeps looping as long as it's false. As soon as it's true, we move on. Alright, that's it. Let's keep moving. Case structure, we talk about that. I mentioned some programming languages support case structure. Python uses an if then else in Python, so we'll cover that when we get to it. But here you have a decision, but now the decision can either be this one, this one, this one, you know, however many you might have in there, or the other. If none of those are true, then it goes to this one. And in between here is where you're doing all the work. In between there is you're doing all the work. We didn't write any pseudocode for that, but we can do that next week or later on. Okay? So, if we're to follow the path, let's just do it here. So you come in, the opcode would look, if the opcode was 2, you know, you entered a value, you know, somewhere's 2 gets passed to here, then it's going to go to here, do all these instructions, and then come down here. Get it? Skips everything else in between. If the opcode was some other number, let's say, or whatever they had here, it skips down to there, does whatever it's here, and then works its way out again. So it selects one of those out of the group. The group could be large, small, whatever. Okay. Then we went into some design. Before we did the design, we talked about variables, memory locations. Okay, we talked about variables could be numbers with decimal points, floats, or they could be integers. Okay, and we'll talk about later on variables can be strings, just characters. For our problem, we just used floating values for the variables. Okay, so let's take a look at our problem here. We have the dowel rod problem. Given the length and the diameter, we need to figure out how much material is it going to take to cover the dowel rod. So basically we need to find the circumference, which then eventually will be the width, and we already have the length, okay, but we need the diameter in order to calculate the circumference, which would give us the width. So we talked about input. We input these two, and then we look up pi. That's initialization. We're going to set pi to be 3.1416, and then we know the output. I should go back here to this color. Let me do this. The output, we want the length and the width, and so our process is going to be to calculate the width. And we can do that by taking pi times the diameter. It's really important. Okay, I said a lot of things important, but you need to be able to figure out this process, okay, before you start designing the solution. Okay, so then we design the solution. We have a start box, arrow going down, touching both boxes. We initialize pi. Arrow, parallelogram is an input box, so we're going to input the length and the diameter. And the students corrected me, I had that wrong in class initially. Okay, then we can do a calculation. Width equals pi times the diameter. Then we can print out our results, and then we stop. Every flow chart that we do will have a start and a stop. One start, one stop. This is sequence because we're just going straight down. We're not looping, we're not making decisions. And then over here I made a legend explaining what the variables are. And what we did at the end was I gave them this code. Okay, all of this are comments. This is crucial. The very first thing has to tell it where to find the Python 3 interpreter, shebang, and then that information. It's important. These are important, explaining the program, and then the actual work was here. And this is in Canvas. Okay, under I have a in-class work. In Canvas where you can find this. And then what the students were to do, they took this code, they could literally copy it, and then they pasted it into their location on work server 2, and then they were to get it to execute before they left. So then they learned the idea. You can take some code, type it up anywheres, and then copy it and put it in where you might need it to execute it. That's it. Let me know if you have any questions.